Can you hear me, right? Good morning. This is Mr. Henry Clement for your chemistry. This is our year 8 division, which I should do 3 chapters with you together. Okay, we will just go through this because we have done this one in the previous week. So this is Mr. Henry Clement. If you like to have some other worksheet, if you like to buy other things, notebooks, topical past paper, or for any other subjects, we are available from geography, math, science, physics, okay, chemistry, physics, and biology. Okay, so any type of the subject you can look for us. We even have some some year 7 to year 9 some school past paper tests. Okay, from all over the UK, Malaysia, Singapore. Okay, you may look there. They often colorful notes. Okay, the particle theories. Okay, we just do the subdivision. So the particle theory says that the solid, liquid, and the state of solid, liquid, and the gas, actually they can explain their movement, their character, their properties, okay, from the particle theories. As the particles in solid, is they have a soft frost and they have lattice. They only move a little bit, which is to and flow. Okay, that allow them just to expand, but not only expand, but not change their shape. Okay. However, the particles in liquid, they have more freedom, because as they are vibrate more, and then as compared to the attraction force between the particles, this is strong enough, so that allow them to slide past each other. Okay, this is the effect of the particle movement. And then when we come to the gas, gases, the gases still have the definite mass, but you need to see the volume can vary because their particles are far apart. How can the particle far apart? Because they have more energy, They have more and more energy that, as compared to the attraction force between the particle, it's like they are so large, okay? And as compared to the attraction, you can say there's almost no attraction effect on the particles. Okay, so the gas particle move freely and at high speed. This is the idea. So for this chapter, you need to read back and then describe, okay, and explain the melting, freezing, evaporation, boiling, and condensing using the particle theory. This is the whole the purpose of this whole chapter. Okay. Also, you may look at the resolving in the particle wave, which is the particle. There's some gap between the particle, and the particle actually can get into them and then dissolve into the substances. Okay, this is dissolving. Okay, the final point of this chapter will be like the gas pressure. The gas, if you apply more pressure, okay, the pressure will increase. However, the more volume will be smaller. Okay, then we talk about atmospheric pressure, which control the boiling, okay, point, okay. And lastly, the diffusion. Diffusion, the new word you need to learn is that this is so-called equilibrium. Equilibrium here is nothing to do with they are to stop moving, but they are constant moving. But just that the moving from up to down is equal, and left to right is also equal. So this is so-called equilibrium. Okay, then we go to the next chapter, which is the element atom. Okay, this is we also done by last 2 weeks. Okay, this is all the elements found and they are dead, but there are still some other element which is found before this date. Okay, and you can see that. So we know that there's a we need to call it as an atom. molecule and ion, right? So actually an element is the smallest particle, so it's called atom. So they cannot be broken down by physical change or chemical reaction into a smaller form of matter. Okay, so we need to know about some property of elements. Okay, we have the general rules which I told you last time, and also the exception. For example, all the matter are solid in room temperature. Okay, except the mercury. And usually the non-matter is gas, but the bromide here is a liquid as well. Okay. There are something other things we call it compound. Compound is a two element or two atoms, okay, or from different elements, okay. They join together in chemical way, chemical reaction, okay. So other things that we need to learn some symbol, okay. So the important thing is we need to learn about the first 20 elements, right? First 20 element, which is from the hydrogen to the calcium. Okay, come. And then next, element, compound, and mixture. Yeah, now we need to learn about the real thing, which is the so-called what is element. Okay, element is the atom with the smallest particle. So there's one type. If one type of atom, we call it one element. So two type of different particle is two elements. Okay, if they join together, you just mix it. It's called mixture. Mixture means that it's by that's chemically mixing together. Okay, and we can separate by using it's an easy way. We just separate. Okay, but the compound is different. Compound is that these two element one, element two, but they already join together and become a new thing. So to separate this one, we need to use some chemical reaction so that we can split together. For example, mixture. I can give you the red bean and the green bean. If I mix together, so there's a red bean and green bean together, but this is the chemically reaction mixing them together, compound making it a compound, or just a mixing to make it a mixture. Definitely, this is a mixture. For example, I can pick up red, green, red, green, red, green, 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 red. You see, I can separate it by just picking up. So this is so called by the physical means. Okay, I have a salt and also the sand. I put together sand and salt. It's very hard, right? But if I take a sheet or take a filter paper, I filter it. So the residue here will be all the sand and then the water. Or no, firstly I need to mix with water first to make the salt dissolve. So the filtrate here is a salt water. Okay. So now I can separate the salt from the sand from the salt. Okay. So here, if the two elements are mixed together, a gray black, if this is a iron and sulfur, if I mix together, you can see some gray color. It's mixing together, but the property are not changed. So this is by this physical means. I just need to pass through, use a magnet to pass over the mixture, and the iron particle will stick to it. If the mixture is shaken with water, the sulfur will tend to float also. Okay. This is the way of the separating these two elements. Okay. However, can you see if this iron and sulfur is heated, a chemical change now take place. A new compound is formed, which is called iron sulfate. It does not have the yellow color of the sulfur and does not have the magnetic property already. The ion don't have the magnetic property just like the iron. Okay. it has its own property, which is a black non-magnetic solid. All compounds have property which differ from the element that form them. Okay, they are already changed. So this one you need to separate. You need to use a chemical reaction. Okay, chemical reaction and equation. Chemists use equation to describe what happened in a chemical reaction. The equation save time and space. Okay, provide the essential information in the easy to read form. Okay, so actually there's an arrow. On the left side of the arrow is a reactant, which is the thing you use to form the products. On my right side, so will be the products. For example, if I get A and B mixed together and I heat it or do some chemical reaction, so the product will be C and B. So this C and D have the element, okay, from A and B, okay, but they have the different properties. For example, just now the sulfur and iron will give you a sulfate, iron sulfate. Chemical name of the compound. So there is some rules, okay, for us to follow so that we can know how to name the compound. Okay. The metal will always come first when later with the halide salt. Okay. And then the ditri, okay, is some words that you need to add for the 2 and 3. Okay. So ATE is I think we have discussed this one also. It's a second name element which is joined to some oxygen. Okay, let's see. So calcium is a metal, so calcium oxide, carbon dioxide, okay, copper oxide, sulfur dioxide, calcium hydroxide, potassium hydroxide, sodium hydroxide, sodium chloride, potassium chloride, calcium chloride, calcium sulfate. Okay, we have done some description from that, so that we will not repeat. Okay, so the mixture, yeah, the mixture is not all chemically bond. So can you see, even when mixed together, the green is still green, the yellow is still yellow. Okay, so this one have the percentage of ratio, which is the yellow A as more, but this one the B will have more, right? So different type of mixture. For example, solid mixed with solid, solid mixed with liquid, solid mixed with gas, smoke. Liquid mixed with a liquid, emulsion. For example, shampoo, yes, hair shampoo. Gas mixed with gas, I think it's a normal gas. Liquid mixed with gas, this mix is a tiny droplet of water. Okay. Gas mixed with liquid, a bubble of gas trapped in the liquid to form. Okay. We have to know about solution. Solution is as a result of the solid mixed into the solvent and stir it to make a solution. So for example, if this is salt, this is water, the salt is a solid, the water is a solvent, and then the salt water is a solution. But somehow there are something which is cannot dissolve. Okay, we call it insoluble. Okay, it's insoluble. There's one word which is, can you see, the liquid that cannot dissolve it into the solvent is called miscible and immiscible. Okay, so we are using dissolve for other thing, which is a solid. Okay, gas. Okay, so if you add something, okay, to the solvent, okay, and then you mix it together, but they're still separate after some time. They are not no chemical or no dissolve. Actually, no dissolve, no chemical. This is not dissolved. Okay, so this is not dissolved. So this is so-called insoluble. Insoluble. Okay. So separating the mixture, so we need to learn about decanting, filtration method, or using another distillation method with a Bachelor funnel, centrifuge, especially you can see in the lab, and by evaporating to form crystallizations, and then also separating different solutes from the solution, which is a chromatography. We have the pencil line here. Be careful, the line must be in pencil. If not, your pen or your die will smudge as well. Okay. So this is how you lay your paper. Okay, standing one. Okay, separating the solvent from the solid. Okay, which is a distillation. Okay, using a condenser to cool down. Okay, and also you can separating two immiscible liquid, which is two liquid which cannot mix together. For example, this is a salad dressing mixer after shaking. Okay, after you shake, carefully, then you can mix a salad. After standing for 10 minutes, then it will become separate again. So you can use this one. You can use the decanting also to pour out the first one, or actually you can just using this separating funnel so that you can take the denser liquid out first and then only the less dense liquid. Okay. So next week we are doing metal and non-metal. So hope you can join me next week. Okay. Later we have the math. I also hope you can join our math class. Thank you very much. This is our revision for the year 8 class. Hope you enjoy this class. This is Mr. Henry Clement. Don't forget to share and like, and so that we can get at least a 50 subscribers. Okay, then I can do it more live stream. Okay, with more subject. I'm planning to do the IGCSE chemistry first, later with some business and economics. Okay, so I hope that you can help me so that I can just use my phone and with a holder. I can start anywhere, anytime. Okay, when I'm free, no need to sit in front of the computer to do the course. Okay, I hope that you can help me to share my link and ask your friend to subscribe me. Thank you very much. Bye.